Okay, folks, this is the first video about reversible reactions, which applies to everybody. Remember, when you see a chemical reaction, mostly the arrow points to the right, and that's it. In other words, most reactions are one way. So in this example here, you can see that the reactants that are referred to as A and B, they are reacting with each other and becoming C and D. When A and B have been used up, the reaction will be over and you will have C and D present. However, some reactions can go in both directions, and we represent that with this symbol here. A double arrow shows that the reaction is reversible. So in this reversible reaction, A and B are reacting to make C and D, and at the same time C and D are reacting to make A and B. The reaction goes both ways. So a good example of reversible reactions are the indicators we use to show pH. So for example here, red litmus reversibly changes to blue litmus depending on the ions that are present. So you don't need to worry too much about the H and the lit and the positive and things. Just think, well, if I've got litmus and I add some acid to it, then the reaction moves to the left and I've got red. And if it moves to the right, it's blue and it's an alkali solution. Here's an example of a reversible reaction that you may have done in class. When you heat ammonium chloride, it becomes ammonia and hydrogen chloride. And when the ammonia and hydrogen chloride cool down, they turn back into ammonium chloride. So the reaction goes both ways. If I want it to go to the right, we'd say go forwards, then I need to put heat in. And to make it go to the left, to reverse, the reactants on this side have to cool down. And that's what's happening in this tube. The solid ammonium chloride here, you can see the S for solid, is being heated. It's becoming ammonia gas and hydrogen chloride gas, which are moving up the tube. And as they cool down, they turn back into solid ammonium chloride, which forms on the sides of the tubes. So in this example, heat going in will move the reaction to the right, and cooling down will move it to the left. And it's really important to appreciate that if you have to supply energy to make a reaction go in one direction, then the same amount of energy, but in the opposite direction, is coming out. So if you give out energy forwards, you need to take in energy backwards, and vice versa.